Hello friends. Even if you have used default or static methods or completely new to it, there are a lot of interesting aspects I'm going to cover, like why Java 8 designers added this feature, or how conflict resolution happens in case of multiple or multi-level inheritance, or what are the best practices and guidelines of using default and static methods. So let me add one interface. Let's call it shape. As you know, traditionally interfaces have all abstract methods. So let's say all shapes must have area. I want to implement this shape. Let's add one class called as circle. Circle is a type of shape. It implements shape, which we added just now. So it is asking us to implement the method because it is declared as abstract method in shape. We need to implement it. So circle has radius. So let's declare radius as a data member. We'll add getters and setters in constructor. As we know that area of a circle is pi r square. So pi and radius square. So radius into radius. Yes, so that's our implementation of circle. Let's try it out with, let's say, shape client, which will have a starting point, that is a main method, and it will instantiate the circle object, and I want to print out area. So let's try to run this and see the output as expected. You can see area of the circle is 314. Let's imagine that the shape interface belongs to some library which is maintained by some other developer. So it belongs to some different project and you are using this as a dependency. Let's say they have added some more abstract method. For example, void print is a method they introduce. So what will happen in this case? You can see that one related problem, which is in circle, right? So what does it say? The circle must be declared either abstract or implement the abstract method print. So that means that if we introduce any abstract method in existing interface, all the known child classes of the shape should implement this print method, and this causes problem because this breaks the code which was running earlier, right? So you need to explicitly declare this print method and then the code will start working. But in case it is just imagine if it is a library, it is not maintained by you and your code breaks because something changed in your dependency, that introduces backward incompatibility. So what we learned is adding abstract methods to existing interfaces causes backward incompatibility. Java 8 gives solution to this problem. So in case you want to add more behaviors to your interfaces and still your child classes should not break, so you should define this as default method. So what are default methods? They start with default as a keyword and they have implementation in the interface itself. So if you see, the error is now gone. So this way you or library developers can basically modify their contracts or interfaces without having any issues with running clients. Okay, now let's give some default implementation. Let's just try it out in our circle. So if you see in circle, there is no shape implemented, right? So as the circle is implementing shape, it will also have this print method available. Okay, let me call this print and let's see what gets printed. And again, as expected, the second sysout statement basically prints whatever implementation you have given in the shapes print method. So pretty straightforward till now. So we have seen that you can basically add different behaviors, give default behaviors to them. These methods will not really break the existing child classes. So this is beauty of default methods. What we have seen is that these are instance methods. Now there are scenarios when you also need kind of utility or class level, interface level methods. That's where the static methods come. For example, what I want to do is I want to basically instantiate a circle object through the shape interface. So how I can do that is, let's say circle, create circle. What I'll accept is a radius. So it should be double radius. Basically it returns new circle of given radius. You can observe that I need not change my child class at all, even after adding static method in my interface. So let's try it out. Say circle1 is equal to, instead of using new, what I'll do is I want to use the static method that I have created. So it gets accessed with name of the interface. I give radius as same 10 and I say circle1 dot print. So another thing I want to do is this is not a sensible message, printing the shape. Instead, I would like to see the area of the circle, right? Or area of the shape that has been calculated. So I'll just change default implementation shape with area. So this gives better information about the shape, and we can call area here. So let's try to run this. And now after running this, you can observe the output. So you can see that it is more sensible message to print, and we could create the shape using our static method which we added in the shape. So let's say tomorrow you want to add rectangle, just add one more static method which creates rectangle, and that's how your shape will act as a factory as well, which creates objects. So this is one good use case of static methods.